Hey everybody. In the last video, we looked at an example of how a single neuron might work to help us classify something, not as a hot dog, not hot dog, but about whether we would find someone attractive, hot or not. We looked at the parts of the neuron, specifically weights and biases, and then how these form the components of two constituent functions inside that neuron, a linear part and a nonlinear activation part. Now the bias term, this term right here, seems to confuse students a little bit. And so I'd like to just take the next couple of minutes to dive in a little bit deeper and show you how that bias parameter kind of establishes how picky you are in your preferences for whether you find someone hot or not. It is basically the threshold in what's called a threshold activation function, that nonlinear part. Basically, if we can move and change values here for our bias, it turns out that that's exactly the same as if we were to change this value right here from, let's say, a 0 to something higher. Let's say you have higher standards or maybe even lower standards. So let's see how this all works. I'm going to clean my screen and then we'll proceed. We've got the neuronal body here and a couple of inputs, x1 and x2. Each one of these inputs takes a weight. We're also going to have a bias parameter, and that's all going to be entered in linearly. And then we'll have this nonlinear part, this activation function, that's going to determine whether this thing fires. And that's going to determine, right, 0 or 1, hot or not. Okay, so what is the model again? We're going to take each one of our inputs. We're going to apply a weight to them. Add those up together. We're going to add a bias. And this time, rather than adding a positive number, let's do a negative number. You'll see why in a second, but it's just a number. And this, we'll just call this something. Let's call it z. That's the first part. This is the linear part. And then the nonlinear activation part is if z is bigger than or equal to 0, our output is going to be a 1. And otherwise, in other words, if it's less than 0, then we're going to output a 0 for not hot. All right, now let me change colors and start messing with this function a little bit. What we're saying here is let's feed in this part right here. That's z. So let's feed that into this part of the function. All right, so we're going to have, so we're collapsing these two different parts into one part. Just algebra, just substitution. So if we have w1 x1 plus, w2 x2 minus b, if this whole thing is bigger than or equal to 0, output a 1. Otherwise, if this term, this guy right here, is negative, we're going to output a 0. Right, so I've just collapsed my two parts into one giant neuron, this part right here. All right, now we can see that, right here, this 0 term, that was kind of like how we, that was like your standard, like your, what it was going to take for your neuron to fire. And here it was just like, hey, if it's positive, it fires. But you can see, I think, with this expression right here, that's really just equivalent to changing b. Like if you change b, you can change whether it fires at 0 or something different. Let's change that color again. we can just bring this b over to the other side of this inequality. Right? We can add b to both sides. And so we get if w1 x1 plus w2 x2 is greater than or equal to b, then what happened? Whoa, my pen is acting weird. Then y is 1. Otherwise, if this guy right here is less than b, then y is 0. Right? We just added a b to both sides. The b's cancel, and that leaves us with positive b. We do that here. B's cancel, and we're left with b on the right hand side of this inequality, and this b on the right hand side of that inequality. Okay, so I think now we're in a slightly better position to see how this bias term is kind of our threshold. Right? That b term is basically us messing here indirectly with that 0. Right? We just do a little bit of algebra, and when we change b, that's as though we were changing the threshold that it would require for us to fire. So in other words, we will fire now if the weighted sum of, I think it was whether you were pretty and if you were intelligent. So the weighted sum of pretty and intelligent, but you had to be like enough pretty and enough intelligent in combination. If you're bigger than your threshold, your dating standard, i.e. your standards, well, then you'll find that person attractive. But if they don't meet your standards and they're below that threshold, then you would not find this person attractive. They would not be hot to you. So that's what the bias term is doing. We treat it like an input, but it's mathematically equivalent to messing with your threshold for activation, your threshold for whether you fire and you get a 1 or you don't fire. Your neuron doesn't fire and you get a 0. So that's all the bias is doing. All right, thanks.